Chapter 5, Relationships in Triangles, by Alexis Gordon and Jenna Cauliflower. A segment bisector is any segment, line, or plane that intersects a segment at its midpoint. If a bisector is also perpendicular to the segment, it is called a perpendicular bisector. In Figure 1, you can see that CD bisects AB at its midpoint at a perpendicular angle. The perpendicular bisector theorem says that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. In Figure 2, AE is congruent to BE. The converse of the perpendicular bisector theorem says that if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. Concurrent lines are three or more lines that intersect at the same point, and that point is called the point of concurrency. The point of concurrency of the perpendicular bisectors of a triangle is called the circumcenter. The circumcenter theorem says that the perpendicular bisectors of a triangle intersect at a point called the circumcenter that is equidistant from the vertices of the triangle. In the figure, that you can see that from the vertex to the circumcenter is equidistant for every angle. The angle bisector theorem says that if a point is on the bisector of an angle, which cuts an angle in half, then it is equidistant from the sides of the angle. The converse of the angle bisector theorem says that if a point in the interior of an angle is equidistant from the sides of the angle, then it is on the bisector of the angle. The incenter theorem says that the angle bisectors of a triangle intersect at a point called the incenter that is equidistant from the sides of the triangle. Below, you can see these theorems in effect. A median is a segment with endpoints at a vertex of a triangle and at the midpoint of the opposite side. The point of concurrency for the median is the centroid. The centroid theorem states that the medians of a triangle intersect at a point called the centroid that is 2/3 of the distance from each vertex to the midpoint of the opposite side. This means that in a triangle, in a median, from the side to the centroid is 1/3, and from the centroid to the vertex is 2/3 of the whole line. You can also state this as from the side to the centroid being half of from the centroid to the vertex. An altitude is a segment from a vertex to the line containing the opposite side and perpendicular to the line containing the opposite side. The point of concurrency for altitudes is called the orthocenter. Here's a chart overall on special segments and their properties. Simplified, the angle-side inequality theorems state that the largest side is across from the largest angle, and the smallest side is across from the smallest angle. The exterior angle inequality theorem states that the measure of an exterior angle of a triangle is greater than the measure of either of its corresponding remote interior angles. These can be seen below in our figures. When writing an indirect proof, there are 4 key steps. The first step is to identify the proof. After you have done that, you must assume the opposite of the proof. Step 3 is to follow this line of reasoning until you reach a contradiction in some known fact, such as a theorem or the given. Step 4 is to write your closing sentence. This leads to a contradiction in blank, therefore state the original proof. Here's an example of an indirect proof. We can see that the given is angle 4 is an exterior angle of triangle ABC, and the proof is the measure of angle 4 is greater than the measure of angle 1. We know that the first step to writing an indirect proof is to identify and then assume the opposite of the proof, which in this case is the measure of angle 4 is less than the measure of angle 1. When you do the third step, which is to follow the line of reasoning, you realize by the exterior angle theorem, the measure of angle 4 must be equal to the measure of angle 1 plus the measure of angle 2,
which contradicts our assumption that the measure of angle 4 is less than the measure of angle 1. This leads to the contradiction in the exterior angle theorem. Therefore, the measure of angle 4 is greater than the measure of angle 1, which would be our final step.
The triangle inequality theorem states that the sum of the lengths of any two sides of a triangle must be greater than the length of the third side.
For example, with the numbers 2, 8, and 11, you add the two smallest numbers to see if they're greater than the third number. 2 plus 8 equals 10, which is not greater than 11, so it doesn't work. 6 and 4 add to 10, but 10 is equal to 10, not greater than, so this also doesn't work. But with 3, 5, and 7, 3 plus 5 equals 8, so this is greater than 7, therefore it works. There is another type of triangle inequalities. These are known as the range of possible measures.
When asked to solve a problem, you have to find the range of possible measures. You will be given, for example, the number 7, 15, and a variable x. Your first step is to make three inequalities with each of these numbers. Your first one will be 7 plus 15 is greater than x. Your second one will be 7 plus x is greater than 15. And your final one will be 15 plus x is greater than 7. Once you have set up each of your inequalities, you simplify them. Here we have x is less than 22, x is greater than 8, and x is greater than negative 8.
Finally, you have your graphing. You need to find the region in which all three, in this case colors, overlap. This region is between 8 and 22. You would write this as 8 is less than x is less than 22. The hinge theorem states that if two sides of a triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second triangle, then the third side of the first triangle is longer than the third side of the second triangle. The hinge theorem is used to make a conclusion about the sides.
The converse of the hinge theorem is very similar and pretty much the same as the hinge theorem, except for you're making a conclusion about the angles. The included angle measure of the first triangle is greater than the included angle measure in the second triangle.
Thanks for watching!